So what we're going to do is we want to find all the important features of, well, in this case a parabola, but we want to do it using parametrics. So tangents, normals, chords, all those sorts of things. So we're going to start off with just finding a chord of a parabola. Now, for this parametric stuff in extension 1, it'll always be just the basic one. We're not going to move it anywhere. So the vertex will always be at 0, 0 for the extension stuff. So x squared equals 4ay will always be the standard one that we're working with. So I'll give 1 point the parameter p, and you'll find we do this fairly often, that we'll call the point capital P and we'll say, oh, it can have parameter little p. So its x1 would be 2ap, its y1 would be ap squared. And we'll pick a second point, we'll call it q, and give it the parameter q. So 2aq, aq squared. All the question really is asking, if we want to find the chord, is find the equation of the line. So it is no different to just normal coordinate geometry. It's just that we're using a lot more algebra, because we're not putting numbers in, we're just using parameters. In effect, what we're doing is generalising to come up with an equation for a chord. So let's find the slope of PQ. You might remember back when we did all those algebraic fraction work, these sort of fractions came up a lot. This is why. This is where algebraic fractions, why all that work was so important. So numerator, I've got a common factor of a, I've got difference of two squares. On the bottom, I've got common factor of 2a. So let's factorise all that. And we get p plus q on 2. So what we've just basically done is the slope of any chord of a parabola then will always be the average of the parameters. So if you know the parameters, straight away you can get the slope. So, oh, well, I'll just average that. And then bang, there's the slope of the chord. So that can be the advantage of working with parametric form rather than the Cartesian form. Put it into our point slope formula, play around with it, and eventually we get it to a form, there we go, p plus qx minus 2y equals 2apq. It sort of contradicts what we've been saying all the years. You know how we always say, oh, straight lines. You either write it as y equals, or you put it in general form. Now, you know how that's been drummed into you? And then now we go and contradict ourselves and say, oh, here's the equation of a line. No, it's not in general form, and no, we didn't make y the subject either. Yeah, we tend to do that, contradict ourselves. Now, a focal chord is a specific chord which passes through the focus. I suppose if I was to compare it with, say, a circle, it's the chord that becomes the diameter. Like the diameter is a chord that goes through the centre in a circle. So it's that sort of comparison. In a parabola, it's sort of like the diameter, I guess, of the parabola. So, okay. There we go, 2ap, ap squared, 2aq, aq squared. We've just worked out the equation of the focal of the chord. The difference is we now know it passes through the focus. So the first thing I would do when I'm doing this sort of question, okay, we'll go and find the slope PQ, like we just did. So it turned out, oh, look at that, it's the average of the parameters. The second thing I usually will do is find the slope of either PS or QS. Doesn't matter which one. I've found PS. And I know P squared minus 1 on 2P. And let's work on, it's the same line. Therefore, those slopes must be equal. So, if it's going to be a focal chord, the slope of PQ must equal the slope of PS. And I can substitute in, play around with that, and come up with this relationship. So the only way a chord could be a focal chord, or pass through the focus, is if the two parameters multiply together to give -1. It's the only way. And you'll find there's a lot of questions where you have to go and prove that little relationship. So often that's the key. You see, oh, focal chord. And if you have to go and prove something in there, you're probably going to have to use the relationship PQ equals -1. So you'll have to prove that little relationship. So that's how we prove it, equate the two slopes. There is another way. If you've already worked out the equation of the chord, there's a quicker way. Because if you've already got the equation of the chord, well, I know that chord passes through the focus. Therefore, if I substitute into it, I know it lies on that line, so I must come up with a correct statement. So if I substitute in naught A, well, naught, so the P plus QX disappears. I get minus 2A is 2A PQ. PQ equals negative 1. A lot quicker. So if I've already worked out the equation of the line, I'd do it that way. I think that's a lot quicker. So we'll try a few of those questions.